7.4, talk about quadratic equations, functions, zeros, and models. An example of a quadratic equation in its basic form is this ax squared plus bx plus c equals 0, where a is not equal to 0. So that means that you've got an x squared. It has to be there. And then before, when we were solving these, when we were factoring things, rather, we would always get them equal to 0. Well, most of the time, that's going to be the case for us. So we need it to be equal to 0. So that means we would want to move this -3 to the other side of our equal sign, and we would get 2x squared minus x minus 3 equals 0. Okay, and then the way that we did it was in this class is we talked about, well, one way we did it is we went straight to the graphing calculator, but I'm going to take you back a little bit and say, well, we kind of thought about, well, what multiplies to -3 and what adds to -1, and we would think of, and actually we would, since this has a 2 in the front, we would have to go to approach that a little bit different. But sorry about that. We need to multiply. Glad I caught that. And we need to multiply the 2 times the -3, which is going to get us, yes. So since there was a variable in the front, in front of the x squared, we do 2 times -3, which is -6. So we would think, well, what multiplies to -6, but still adds to -1? Okay, and so we could think of this, and there's some strategies we used on the graphing calculator. I'm not going to go to them now, but -3 and +2, -3 times 2 is -6, -3 plus 2 is -1. So that's the combination we wanted. Since there was a number in front of the 2, we would divide both sides by 2, and we would reduce that fraction. This won't reduce any more than it already is. So we would use that to make the factoring. So we would put the denominator in front with the x, and then the -3 would go on the top. And then this will reduce, it's just 1. So that would be x, because we don't have anything. We wrote it 1/1, x, and then +1. So that's going to give us our, so when we think about this, we've got -3x, and then the outside's going to give us our +2x. That's going to combine to be what we need in the middle. So then after we do that, we would want to break this down even further and say, well, when is 2x minus 3 equal to 0? And when is x plus 1 equal to 0? And we would solve that. And I don't know if you remember this, but the answers would always be whatever you had up here. So the opposite of whatever we had up here. So if we had -3/2, we would end up with +3/2 when we solve this one. When we solve this one, we're going to end up with -1. And so x is equal to 3/2 and x is equal to 1, -1, sorry, would be our answers to that. Now I do want to remind you, let me pull up the graphing calculator really quick. We don't have time to do every one of these back and forth on the graphing calculator, but I do want to show you, just to remind you that you can do these on the calculator to solve them. So if I go to my graphing calculator and I work the one that we just had, so what you would do is go to your apps and you want to pick number 9. And this is the poly root finder. We do want it to raise to the second power. So we're going to hit Next. And we want to type in the equation that we had, which ends up being 2x squared minus, we just had 1x. And then when we moved the 3 to the other side, we had a minus 3. Okay, and then we want it to solve it. And see, these are the answers that we got, -1 and 3/2. So you can do these problems, especially when they come out even like this on the graphing calculator. So let's go back. Okay, well, what about this one? This one, we could absolutely use the graphing calculator. This one doesn't have a number in the front, so it's a little bit easier. We would say, well, and it's already solved for 0. So what multiplies to 6 and adds to 5? Well, that's going to be 5 and 1. No. Right? 5 times 1 is 5. So that's not going to work. Okay. So what multiplies to 6 and adds to 5? I bet you can think of it. 2 and 3. 2 times 3 is 6. 2 plus 3 is 5. And so we didn't have to divide out on this one because it didn't have anything in the front, like this one over here had the 2 in the front. This one doesn't have anything. So our answer, our factoring would be x plus 2 and x plus 3. If we wanted to go straight to the answer from this, remember it's going to be the opposite of these things. But the way that we do that is we say, well, when are these things equal to 0? And we solve them. And these are the two answers we get. Well, what happens when you're solving a quadratic? Okay, when you graph, if we were to graph a quadratic looks like a U. Okay, and most of the ones that we mess with are going to be facing up. And the solutions to a quadratic are where they cross the x-axis, which is why some of them have two answers. So this one would cross at -2 and 3, and those would be the solutions to the quadratic. It's just a graph that makes a U. It's called a parabola. The solutions are wherever it crosses the x-axis. Now, you do need to recognize that sometimes it's possible to have a quadratic that looks like this. Okay, how many answers is that quadratic going to have? None, because it never crosses the x-axis that we're talking about right here. It never crosses this line, so it's not going to have any answers. It's even possible to have something, a quadratic that maybe looks like this. How many answers is that one going to have? It's going to have one solution that's right here because it only crosses it one time. So it is possible to not get two answers on every one of these. Sometimes you might get one or none. So some quadratics are really easy to solve, and you want to look for things like so let's look at some. If I've got x squared is equal to 121. Okay, that's an example of one that's going to be really easy to solve because all I have to do is take we know that to undo a squared, we can take the square root on both sides. And now we know that the square root of 121 is 11, but we also know that it could be -11. So it has two answers here, 11 and -11. And a lot of times, the way that will be written is plus or minus 11. And I know in my math labs, there's actually the symbol, so you don't have to write 11 and -11, okay? If I see something like this, I can solve this pretty easy if I add 22. And here's the thing with this. I know to do this because all I have is an x squared as a number. So I know I'm going to be able to get it by itself. On the previous problems, we made sure that they were equal to 0, which you're going, well, why would I need to, this one already equal to 0? We could still work it the other way. It's just easier to work this one this way. So you're going to be looking for, if you just have two numbers and you don't have that middle term. So in other words, if I have x squared plus 3x equals 22. Well, now I've got three things. This one only had two, including the 0. So if it's like this, I'm going to have to subtract 22 and work the problem out. But that's not what I have. I just have two numbers besides 0. And if I have that, it's going to make it easier for me to work this problem. Well, to get rid of a squared, we have to take the square root of both sides. Well, we know a lot about square roots now. We know that we want to see if we can pull anything out of this. 2 will go into 22 11 times. 11 is prime. So the answer is no, I cannot. But remember that you always want to put plus or minus whatever the answer is, because it could be either or. Okay. What if I've got something, let me figure this out. Still solving here. If I've got x squared is equal to negative 24. Okay, well, we know to solve an x squared, we have to get rid of the x squared. We have to take the square root. Okay, now, we know something about this. We know that we can't get a real number if we take the square root. But we also know now that we can divide that into negative 1 times 24. Remember? So remember that in 7.3, sorry, can't spell today. So remember in 7.3 that we said if we have the square root of negative 1, it's I, and that I squared is equal to negative 1. Well, this would be I, we could pull that out. Remember that we're going to have a plus or minus here. And then we would need to look at 24. 24, 2 will go into 24 12 times, 2 will go into 12 6 times, 2 will go into 6 3 times. So we would end up still having 2 times 2 times 2 times 3. We could pull out a 2. So 2i, this 2 is going to come out with this I, and then we would have 2 times 3 left underneath, which would be the square root of 6. Okay, if we've got x squared equals 45, we're going to take the square root to get rid of the squared. Got to take it from both sides. Going to look and see what is 45 made up of. 2 won't go. 3 will go 15 times. 3 will go into 15 5 times. So really, this ends up being 3 times 3 times 5. So we could pull out a 3. We'd leave the 5 underneath. And remember that it's always plus or minus when you're talking about square roots, because it could be the positive or the negative answer. Okay. We have a couple more of these that we need to solve. So if we've got 5x squared equals negative 55, well, we need to get rid of the 5, so we would divide by 5 on both sides. So x squared equals negative 55 divided by 5, which is negative 11. To get rid of the squared, we would take the square root of both sides. Well, that negative 11, we're going to need to divide into negative 1 and 11 times 11. Remember that the square root of negative 1 is I. So this is really going to be plus or minus I times the square root of 11, because 11 is prime, and I wouldn't be able to do anything with that. Okay, one last one like this. 2x squared minus 10 equals 0. We're going to add 10. So 2x squared equals 10. Divide by 2. X squared equals 5. To get rid of a squared, you're going to want to take the square root. So x is plus or minus the square root of 5. 5 is prime. I'm not going to be able to do anything with that. Okay, so that's one type of quadratic and how to solve it. Okay, you can also solve a quadratic by looking at the graph. Okay, so if you're just given a graph, we're just given a graph, and let's say that our graph, we talked about quadratics and the fact that the way that they look, it's like a U. So if this is my quadratic, and I've got this, this, this. This is labeled 4. So this would be 2. And you need to be careful because sometimes they don't go up by 1, 2, 3, 4. Okay, so sometimes this is going up by every 2 numbers. To solve this quadratic, all I have to do is look at the x-intercepts. Where does it cross the x-axis? Those are the answers. So solution to this would be, this quadratic that's drawn here would be 2 and negative 4. Okay, so let's look at another one. Okay, so say I'm looking at a quadratic that does something more like this. This one's facing upside down. This is 1, 2, 3, negative 1, negative 2, negative 3. So the solutions to this quadratic are where it crosses the x-axis. So negative 1 and 3. If it's graphed, it's so easy to find the answers because we're just looking for where it's crossing that x-axis. Let's look at one more of these. Okay. Well, this one, it's more like this. And so this is 1, 2, 3. So it'd be negative 1. So this is one of the examples where it's only crossing one time. So the solution would be right here where x is 1. And it would not have another solution. So we have some wording here. The wording is, what are the x-intercepts on this one? Well, the x-intercepts are actually points. So this point right here would be the point negative 4, 0. The other x-intercept is right here, which would be the point 2, 0. And then there's another term that says, what are the zeros of the function? Well, when you list the zeros of the function, you're going to list 2 and negative 4. Okay, so on this one, when you say, what are the x-intercepts? You're listing these as points. This point would be the point negative 1, 0. And this point would be the point 3, 0. When it actually asks you what the zeros are, which is just a fancy way for saying what's the answer, you're going to say, well, it's negative 1 and 3. Okay, my x-intercept on the last one, well, there's only one x-intercept here. It's at the point 1, 0 right here. And my zeros are going to be 1 because there's only one time that it happens, and it's when x is equal to 1. Okay. Now, we have one last thing that we need to talk about, and that's this quadratic formula. And there is an app program to put on your calculator that will do the quadratic formula for you. I do not, and there's several things that on the computer that you can also search for that would take you step by step in doing the quadratic formula. I'm going to show you how to do it using the actual quadratic formula. But know that you can always check your work using one of those programs. So at the very beginning of this lesson, we talked about how ax squared plus bx plus c was the equal 0, was the general form of a quadratic equation. And the reason that we need a quadratic equation is sometimes in a problem, we can't think of what multiplies to another number and adds to the number because perhaps there's not anything that will work. And what that means is there is something that will work, except for it's a decimal and we're not able to think of that in our head and come up with the perfect thing. So when that happens, there's this nice little formula we can use to figure out how to do the quadratic, how to find the answers. Okay, so here's our first problem. And I'm going to work several of these. If you're catching on and you need to log out, that is fine. But I want to make sure I give plenty of examples of this. So in this problem, we've got 3x squared plus 2x is equal to 7. The first thing I would do is get this equal to 0. So we would subtract 7. That's going to give us 3x squared plus 2x minus 7 is equal to 0. Now remember, if we were going to do it this way, we would say 3 times negative 7 is negative 21. So we would be trying to think of something that multiplied to negative 21 but adds to 2. Okay, well, there's just not anything that multiplies to negative 21 and adds to 2 that I can think of. So this method's not going to work, which is why we had to come up with something else. Okay, so I'm just going to take that off because we cannot think of anything that multiplies to negative 21 that adds to negative 2. So when you look at this formula, you're going to have to pick out some things. The first thing that you're going to have to pick out is your A and your B and your C. So when I look at this problem, A is always in front of x squared. So in my example, 3 here would be the A. Okay. B is always in front of the x raised to the first power. So in my example, 2 would be B. Okay. C right here is the constant term that's out there by itself, that there's nothing else attached to it. And my C would be negative 7. Okay, next thing I want to do is I want to plug it in this formula. So x is equal to, there's a negative sign, so I would put the negative sign. I'm plugging in something for B. Well, we know that B is equal to 2, so I'm plugging in B. Okay, the next thing is plus or minus. I'm getting that from my formula right here. Got a big square root sign. Now I'm plugging in B again, and B is 2 squared. And then we've got minus 4. I'm just following my formula. And then it says times A. Well, A is 3. And then it says to plug in C. And C is negative 7. So I'm plugging this stuff in this formula. On the bottom, we've got 2 times A. And A, we said, was 3. Okay, the next thing you want to do is slowly start simplifying this. Well, negative 2 is just negative 2, plus or minus, okay? Your calculator can probably handle all of this at one time, so it would be okay to type in your calculator 2 squared minus 4 times 3 times negative 7, okay? And all of that comes up to 88. Our calculator can handle, or our brain can handle 2 times 3, which is 6. Okay, and then the last thing you're going to want to do, you're almost done. The last thing you're going to want to do is you're going to want to see, okay, does this 88 simplify? So if we find the prime factors of 88, 2 will go into 88 44 times. 2 will go into 44 22 times. 2 will go into 22 11 times. 11 is prime, so we would stop right there. And we would be able to pull out a pair of 2s, and then we would have 2 times 11 left. So I've got negative 2 plus or minus I could pull out a pair of 2's, and then underneath the square root, I have 2 times 11 left, which is 22. And I have all of that over 6. I'm kind of running out of room. So what does that mean? That means that I've got negative 2 plus or minus 2 square root of 22 over 6. Okay. And we are definitely going to have some more room to really, because I want to break this down and talk to you about what the final answer is. So we had negative 2 plus or minus 2 times the square root of 22 over 6. Okay, well, that's actually two answers. One of the answers is negative 2 plus 2 square root of 22 over 6. The other answer is negative 2, because I see plus or minus here, minus 2 square root of 22 over 6. Well, we could even break that up a little bit farther because it's over the same denominator. And we could reduce this fraction. Negative 2 6, well, that's just negative 1/3. And then we could reduce this part of the fraction, 2 6, which is 1/3. So that would end up being, we wouldn't put the 1 there because it would just be understood. And 2 6 is 1/3. So we would put the 3 underneath. Could do the same thing on this part, negative 2 6, but this time minus 2 square root of 22 over 6. Well, that's going to be negative 1/3, but this time it's minus the square root of 22 over 3 when we reduce that fraction. Okay. So still using this formula, x is equal to negative b plus or minus b squared minus 4ac over 2a. This time they're asking us to solve x squared plus 5x plus 8 equals 0. So we're going to have to pick out an a and a b and a c. Remember that a is always going to be whatever comes in front of your x squared. B comes in front of x, and c is your constant number out here. So we don't have a number in front of x squared. So how many x squareds do we have? Well, we know that's 1 if there's no number there. B times x, so 5 would be b, and c is 8 here. Now we're going to go in and plug it in our formula that we have. So x is equal to negative. Then they want me to plug in a b. B is 5 minus, this time we're squaring b, so 5 squared minus 4 times a, which is 1, times c, which is 8, all over 2 times a, which is 1. So negative 5 minus, remember the calculator can handle this stuff underneath. So I would type that in just like it is with the parentheses around the 5 and everything. Okay, that ends up being negative 7, which we should have our antenna up because we've got the square root of a negative number here, divided by 2 times 1, which is just 2. So, and remember that this is plus or minus, and I'm getting that from the formula here. So we've actually got two answers. One answer is negative 5 plus the square root of negative 7 over 2. The other one is negative 5 minus the square root of negative 7 over 2. Okay, and we know from doing this that this right here, the square root of a negative 7, let me just bring this out here. The square root of negative 7 is the square root of negative 1 times 7, which means I times the square root of 7. So plus I square root of 7 over 2, and negative 5 minus I square root of 7 over 2, because that's going to end up being imaginary. Okay, so Those are our two answers. X is equal to both of those things. Okay, let's do just a few more of these. Like I said, if you've got it and you need to log out, that's fine. I just want to make sure I cover plenty of these. So if I want to solve x squared plus 4x minus 7, I mean, the obvious thing that we want to do is if we can think of something that multiplies to -7 and adds to 4, that's what we want to do. But this problem isn't going to be like that. It's not going to work out. We won't be able to think of that. So x is equal to -b plus or minus b squared minus 4ac over 2a. That's the quadratic formula. We need to pick out a and b and c. It's already solved for 0. So we know that a general quadratic is ax squared plus bx plus c. So a here would have to be a 1 because there's no number in front of that x squared. B is 4 and c is -7. Okay, so now we want to plug it into our formula. X is equal to negative b is 4 here. Then we've got 4 squared minus 4 times 1 times -7, which is c, all over 2 times 1. So I've plugged in the numbers. When I plugged them in, I put them in parentheses. Okay, so I've got -4 plus or minus. The calculator can handle all of this. 4 squared minus 4 times 1 times -7. I would leave it and type it in exactly like that to figure out what it is. But I would not try to type all of this into the calculator at one time because it's going to give you issues. I'm getting 44 here. 2 times 1 is 2. So we know that we're going to have to kind of look at 44 to see if there's anything we can pull out of that. Okay, and there are a pair of 2's. So I would have x is equal to -4 plus or minus. We could pull out a pair of 2's, but we still have an 11 underneath over 2. Now, we got a couple of ways to look at this. Some students can see this right away, that 2 goes into every one of these 3 things. Other students have to kind of break this up and go, okay, I can do this, break this up into 2, and they can reduce these. So that would be one of them when you say, and the other one's going to be when you say subtract. So -4 divided by 2 is -2. These 2's would cancel out, so we would have plus the square root of 11 over here. So that's one of my answers. -4 divided by 2 is -2. These 2's cancel out and will be minus the square root of 11. So this and this would be my answer as to where it crosses the x-axis if I solve it. Okay. What about this one? We've got 4x squared minus 7 equals 0. Well, first thing is I'm only noticing 2 terms. So this one should be a little bit easier for me to solve because I don't have to do the quadratic. I just have these 2 terms here. So I could just solve it using like simple algebra. So if I can use the quadratic formula if I want to, but it would be much easier if I recognize, oh, there's just 2 terms here. I can add 7 to the other side, divide by 4. Those cancel. X squared is equal to 7/4. Then we would take the square root of both sides. So x is equal to plus or minus the square root of 7/4. And that we know could also be written plus or minus the square root of 7 over the square root of 4, which we know is plus or minus the square root of 7 because the square root of 4 is just 2. Okay, so we didn't have to use the quadratic formula on that one. And the reason that I didn't use it is because I noticed that there were just 2 terms. Okay, and I will go, I know I'm going a little bit fast. I'll go and I will post this video after we get done with this and the notes that go with it. So on this one, I don't have 2 terms, I have 3 terms. So I'm going to solve this for 0, move that 2, -2 to the other side. Okay, and then if I can think of something that multiplies to 6 and adds to -9, that would be great, but we know we can't. So we know that this is in the form ax squared plus bx plus c. So a would have to be 3 here, b is -9, c is equal to 2. So x is equal to, sorry, got ahead of myself. X is equal to -b plus or minus the square root of b squared minus 4ac over 2a. So we're going to plug in what we've got. Now, this one's a little bit confusing because b is negative right here, but this negative is in the formula. So both of the negatives have to go. The negative from the formula and the negative that I'm plugging in for b. Okay, b squared is -9 squared minus 4 times a, which is 3, times c, which is 2, over 2 times a, which is 3. Okay, so -9, that's going to be 9, plus or minus. Okay, we can type that whole thing in the calculator, -9 squared minus 4 times 3 times 2. It's 57. I'm pretty sure that 57 is prime. Nope, it can be divided by 3, and 57 divided by 3 is 19. 3 times 19, though, is still not going to get me factors I can pull out. And I've got 6 on the bottom, 2 times 3. So I've actually got 2 answers here. One of my answers is 9 plus the square root of 57 over 6. The other answer is 9 minus the square root of 57 over 6. And then the last step is to see if you separate these out, if they can reduce. Okay, well, 9/6 is equal to 3 over 2. So we could do that. This square root of 57 over 6 is not going to reduce. But we can say 9/6 is 3/2. And that's going to reduce to square root of 57 over 6. So this answer and this answer would both be, they're both places where this thing's going to cross the x-axis. Okay, what if I have 5x squared equals -10x minus 3. First thing I want to do is solve this for 0. So I'm going to move the 10x to the other side. So 5x squared plus 10x is equal to -3. We're going to want to move the -3 to the other side. So 5x squared plus 10x plus 3 is equal to 0. Okay, so now A is going to be 5, B 10, C is 3. So we're plugging it into our quadratic formula. So negative B, which is 10, plus or minus B squared minus 4. A is 5 here, C is 3. All over 2 times A, which is 5. So we want to start chiseling away at this thing. The calculator can handle the 10 squared minus 4 times 5 times 3, which is 40 over 10. We would want to look at the 40 and see if we could pull anything out of that. 2 will go into 40 20 times. 2 will go into 20 10 times. 2 will go into 10 5 times. So we've got a pair of 2's that we could pull out. So negative 10 plus or minus 2 square root of 10 over 10. We know that this is two answers. It's negative 10 plus 2 square root of 10 over 10 and negative 10 minus 2 square root of 10 over 10. Okay. Now, when we start breaking that up even further, this is going to divide out. So we've got negative 10 plus 2 square root of 10 over 10. So both of these, let me just erase that. So let's look at this. We've got negative 10 over 10 plus 2 square root of 10 over 10. Well, these are going to cancel out. We would just be having negative 1. 2 and 10 can both be divided by 2. 2 will go into 2 one time. So then we would just have plus square root of 10 over 5. If we divide 10 by 2, it's going to give us 5. Well, the opposite of that would be negative 1 minus the square root of 10 over 5. So both of these would be answers when we reduce those two. So I hope that that gave you some examples about how to do the quadratic formula. Also in my math labs, there's some really good examples of that. I tried to also post extra videos in my math labs that will help you. Next week, we will finish the rest of the sections so that after Thanksgiving, we'll just have to review for our final, take your final test, and we should be done.